and then I got some more practice for you to work on. So when we were talking last, we were just looking at multiplying fractions. And so the fractions, we talked about can come in basically three forms. So they can be improper, they can be proper, or they can be mixed numbers. But in general, anytime you want to work with fractions mathematically, we typically want to convert them into like propers or impropers. Mixed numbers just aren't really very ideal for doing math computations. So, so for example, let's say that you had something like, let's say we had a mixed number like 1 2/3 times, let's say, I don't know, a whole number. Okay, so in this case, neither one of them are proper or improper fractions. And so you got your mixed number, you got a whole number. So what should we do here? How do you convert? Do you remember how to convert the mixed? Yeah, it's like multiply the denominator by the whole number and then tack on the numerator. So 3 times 1 is 3 plus 2 is, this would be 5/3. And then 5 we would rewrite as 5/1. So sometimes people, when they see the different forms, like when you throw in whole numbers or mixed numbers, it kind of causes people to just like freeze and just not do anything with it. But you don't have to. Just convert everything into an improper fraction, and then now that looks like a nice, easier problem that we're more familiar with, because when you want to multiply fractions, how do you multiply fractions? It's just straight across for multiplication. That makes life nice and easy. So then this would be 5 times 5 is 25, 3 times 1 is 3. This one can't be simplified because there's only 5s in the top and 3s in the bottom. So this is a perfectly reasonable answer, but since that's improper, how could you convert that into a mixed number? Yeah, you just do 3 into 25. Well, how many times does 3 go into 25? 8 times, right? Because 8 times 3 is 24, so the remainder is 1. So this would be 8 and 1/3. So either one of those answers would be correct. It just, depending on the quiz or the application. So if I was just looking for the answer from the person in a math class, I'd be perfectly happy with the improper answer. But that's just a really weird way to explain 8 and 1/3 to most people. So you never order like 25/3 of a yard of fabric at the fabric store or something, right? You're gonna order 8 1/3. So anyways, seem vaguely familiar, hopefully? Of course, always remember to simplify fractions if you can. This one didn't need to be simplified. So then dividing fractions is really not any more complicated. So what happens is, well, I'll just give you a simple example. So for example, what do we know? You know what, say, like 10 divided by 2 is, right? Well, what is it? Yeah, it's just 5, right? Well, another way to write 10 divided by 2, you could write it in its like fraction form, right? Like 10 divided by 2 is the same as 10 over 2. But that's just like 10 times 1/2. I'm showing you this for a reason. It looks really weird. But I just kind of want to show you the relationship between division and multiplication, right? So what happens is dividing by a number. So 10 divided by 2 is equivalent to saying 10 times 1/2. Is that true? Everybody agree with that, more or less? So then what it tells us is it says that you can rewrite division problems as multiplication problems. You just have to, what do you notice? This was divided by 2. When we turned it into multiplication, what do we do with this 2? It went into the denominator, right? So what happened was, this is like 10 divided by 2 over 1. So we can rewrite it as a multiplication problem, but then what you have to do is you have to reciprocate or you have to flip the fraction. It turns out that division actually isn't really its own operation. It's just multiplication with fractions. And that's why division and multiplication are on the same order of operations. You don't actually like respect one over the other. Addition and subtraction are the same way, because addition or subtraction is just addition of negative numbers. And so they're on the same order. That's why one's not like better than the other. So anyways, the point is that if you want to divide fractions, in general, then, if you have, say, like a over b divided by some other fraction, c over d, you can just turn it into a multiplication problem, and you flip or you reciprocate the second fraction. It's always you always reciprocate the second fraction in a division problem with fractions. So dividing by c over d is the same as multiplying by d over c. Just flip. Yeah.
Can you do like the a to d, like the cross thing?
You're thinking, no. So you're thinking across multiplication, I think.
Yeah.
And that's only, you're thinking of like, if you have an equation.
Oh, yeah.
So that's something called a proportional equation where you have a fraction on both sides. And then you can use cross multiplication to simplify it. And we'll do more of that later on. But if there's not an equal sign, cross multiplication only works when there's an equal sign between the two fractions. Okay. All right, so I'll give you some examples. So for example, if I had, say, I don't know, let's say like 2/3 divided by 9, wait, I don't want to go that way. I want to put, it doesn't matter, we'll start there. 9/10. Okay. So anytime you see division associated with fractions, you're just not even going to deal with it. You're just going to rewrite it as multiplication. And then which fraction gets flipped? It's always the one that comes after the division sign. And so this actually becomes times what? 10/9. So you reciprocate the second one or you flip the second one. And then you just follow the rules of multiplication. So then it's just 2 times 10 on top is 20. 3 times 9 on the bottom is 27. Can that be simplified? Mm-mm. And you can look back at the original product to see that it can't be simplified. Because remember I was showing you last time. If it can be simplified, you can do it in this step. But it's all factors of 3 at the bottom, and then 2s and 5s at the top. So they don't have anything in common. So anyways, that would be the answer. Okay. What if you have... Any questions on that one? See, and then the other thing too is if you remember that, mixed numbers and whole numbers aren't really a problem, then even if they pop up in division problems, that's okay. So like let's say what if we had like 5 divided by, say, 2, I don't know, let's just say 5 divided by 2/5 or something like that. Okay. So there's 2 things you need to do to make this look nicer. What's one of the things we got to do? Yeah, first off, we'll rewrite 5 as a fraction. And then the other thing we're going to do is we're going to reciprocate it, turn it into multiplication. So first, that 5 is just going to become 5 over 1. And then, because we have division of a fraction, we're just going to immediately rewrite that as multiplication or reciprocal. Right? And then it's just straight across. So if you multiply this one straight across, what do you get? 25 on top over 2 on the bottom. Okay? So that's a reasonable answer. If you want it as a mixed number, how many times does 2 go into 25? 12 times with 1 left over. So 25 over 2 is the same as 12 and a half. Okay?
Are you going to ask us to simplify?
You should be able, typically I'll only ask for it in one form. So typically in a math class, like in any math class, if it's not specified, then just a simplified improper fraction is always okay. So if I want something more like a mixed number, I'll specify, like give your answers as a mixed number. But you should be able to do it in both. You should feel comfortable doing both. Now, question though, this is weird though, because if you take 5 and divide it by something, does it make sense that you could actually end up with a bigger number? How does 5 get divided by something and then somehow end up?
Because you're taking it out of a whole number.
You're taking what out of a whole number?
Fraction out of a whole number.
The 2/5?
Well, I guess it doesn't really make sense, but it does make sense because it's math.
It's not wrong, so it does make sense, but why? Normally when you divide things up, you make them smaller, right?
Yeah.
So, like if I just did 5 divided by 2, that would be 2.5. It gets smaller if you divide it up. So how come here you're dividing 5 by something and then somehow the solution's coming out bigger than what you started with?
Because if you divided 5 by 2.5, you get 2
Say that again.
So if you divide 5 by 12.5, you should get 2 fifths.
That's cool noise. Yeah, that's true. That is true, actually. If you did 5 divided by 12.5, it would circle you back to 2.5. That's actually true. But that's really just mathematically, that's what it would come out to be. But I'm talking like conceptually, why does it make sense that you can take a number, divide it by another number, and then somehow end up with a bigger value? Because math. Well, okay, so think about it this way. So I'll come over here and red. This is kind of, so I don't have to write this down, but so think about like something that makes more sense. Like 10 divided by 2 is what? 5. Okay, there's 2 ways to think of that division. One way is to think about, you could think of this as 10 cut in half, right, equals 5. Another way to think about this is that 2 goes into 10 how many times? Right? So you can go ahead, sorry. Yeah?
So are you saying that like 2 fifths goes into 5 12.5 times?
Exactly. That's why, because this doesn't make any sense. You're cutting 5, you're cutting in 2 fifths. Like that doesn't make a lot of sense intuitively. Like up there, 10 divided by 2, cutting in half, that makes sense. But if you think about it this way, 2 goes, what you really figure out is how many times does 2 go into 10? It goes in 5 times. Right? Well then, if you look at it this way, well how many times does 2 fifths go into 5? Well, it's more than 5 times because 2 fifths is smaller than 1. Right? Because like, if you think about, if you put together 2 fifths, right, and then another 2 fifths, and then another 2 fifths, right? Well, you put it in once, you put it in twice, you have to put in 2 fifths 3 times just to get over 1. And so then, how many times are you going to have to do, how many times does 2 fifths go into 5? It actually goes in 12 times and a little more. So you can actually take a number and divide it by a fraction, and then your value is actually going to come out bigger, and the reason is because you're dividing by something smaller than 1. So if you divide by numbers bigger than 1, you get smaller. If you divide by numbers smaller than 1, it actually gets bigger. And it does actually. It's not just like nonsensical, crazy math stuff. It's just because that's literally how many times 2.5 goes into 5. Or 2 fifths goes into 5, so. Yeah? Okay. So, the rules for like mixed numbers or anything like that, same things applies. What if I had something like, how about 10 elevenths divided by 5? If I had something like that. So, what's the first thing we should do here? Yeah, well, so we're going to have to change the multiplication, but first we also need to do what? Yeah, we need to make sure everything looks like a fraction, right? So this is like 10 over 11 divided by 5 over 1. Then you got to turn it into multiplication. Well, which one gets flipped? It's the second one, right? So it doesn't have anything to do with like which one's the whole number, which one's the fraction. The only way you make your decision on which fraction to flip is it's always the one after the division sign. So then now we can multiply. Now this one happens to be simplifiable, right? Because I got a 10 in the numerator and a 5 in the denominator. They're both divisible by 5. So 10 divided by 5, 2. 5 divided by 5 is 1. So you're just left with 2 11ths. Be your solution there. Yeah?
You
Questions on that one?
can't
You can, yeah. If you multiply straight across, then you would have come up with, if you were to do that, then it would have become 10 over 55. But then you'd have to realize that both of those have a 5 in them, and then that would take you back to your simplified answer. So yeah, it's all, if you don't like the simplifying ahead of time, it's not like required. You can just multiply and then reduce. That's totally fine. Sometimes what happens is just like, if the numbers get big and they have weird factors in them, that makes it hard. Sometimes you don't always recognize which numbers could be taken out once you get to this step. And the other thing too is it just introduces more places to make mistakes. But it's not really wrong. If you do them both right, then you'll get the right answer either way. Okay? You guys feel pretty good about that? Okay. Then, again, if we throw in like mixed numbers into the thing here, so let's say we have like 12 and 2/7 divided by, that's going to be a really big number, isn't it? It doesn't matter. Let's go with, I don't know, 10 or something. So here I've got a fraction, here I've got a whole number. So what do I need to do with both of them? I just need to convert them into impropers, right? So like 7 times 12, what does that give you? 84? And then 84 plus 2 is 86 out of 7. Okay. And then 10 should be rewritten as what? 10 over 1. Yeah. And then once we see, now we've got it both. It looks just like a fraction division problem. So now we know which one gets flipped. It's got to be the second fraction. So 10 over 1 becomes 1 over 10. And then you just follow the rules. But this one, what are those both divisible by? They're even, so they're both divisible by 2. So divide this by 2, you get 43. And divide this by 2, you get 5. And that's about probably as far as you can go. And so on top, you're just left with 43 times 1. On bottom, you got 7 times 5. And then that would be, what, 43 over 35. And then that'd be your answer. Now that's an improper, technically, right? So if you wanted to turn that into a mixed number, you just put 35 into 43. Well, it only goes in, what? One time. 1 times 35 is 35. So then your remainder here would be 8, I think. So then it would be, this would be the same as 1 and 8/35 if you were going to turn it into a mixed number. Okay? Seem reasonable? Everybody feel like they can divide fractions? So I had a couple at the bottom of the last worksheet I handed out last week, but I got a bunch more here. Just reviewing some multiplication and then also throwing in division. There is one other thing that you will run into occasionally, and this is going to come up when we get to proportional equations. What you'll run into sometimes is something called a complex fraction. Okay, and what that means is it's like a fraction in a fraction. Okay, so it'll look something like 3/4 over like 1/2. So you actually get a fraction inside of a fraction, right? So how do you handle something like this? Because this is obviously, this can't be the right way to write that fraction. Like it can't be the easiest way or simplified version. So what should you do? How could we simplify that? Yeah, remember that fractions are just another way to denote division. So we can rewrite this as a division problem. So this is 3/4 over 1/2 is the same as saying 3/4 divided by 1/2. And the number on bottom is the one that comes after the division sign. The numerator comes first when you convert it into a division statement. Then we know how to handle this because it's division of fractions, so we should rewrite it. And which one gets flipped? The second one gets flipped, yeah. So you turn it into a division statement. You turn that into multiplication, and then you just finish it off. So these are both divisible by 2. So you're just going to have the answer here just be 3 over 2. And practicing simplifying them, it's like, it kind of seems like, why would you ever have a complex fraction? And the answer is you really wouldn't very often, but there are situations we're going to come across later on. Like if you cross multiply, you may end up with like a fraction on top of a fraction, and then you want to know how to simplify those. And this is the key. Rewrite it as division, and then just work it out from there. And even if it has, even if there's whole numbers involved, so say like you had, I don't know, let's throw, say like 2/5 over, I don't know, let's say -4 or something like that. We'll throw a negative number in there, wow. Okay. So you're looking for the bigger line is where the division symbol goes. So even though this is a whole number, that's not really a problem. We can still rewrite it as a division problem. So this would become 2/5 divided by -4, which we would also turn into an improper fraction at that point, so that we can work with it. And then which one gets flipped? Always the second one. It'll be like that. Yeah. And then it's just straight across. But this one is also simplifiable. So it's going to be 1 on top, 10 on bottom, and it's going to be negative, because the positive times the negative is always negative. So. Okay? All right. And so simplifying complex fractions, we're just going to keep it kind of in our back pocket until maybe chapter 6 or something, and then it'll come back. We'll use it more. But. All right. Any questions on any of those two examples? They seem pretty straightforward. Okay, so I'm going to pass out some practice for you guys to try with these, just to make sure we're all on board. Give these a try today. Excuse me. So, as always, you can work together or in groups, or you can ask questions. So let's take like, what's the date? What, 11:50 something? Yeah, I'll take maybe 15. I'll see where you're at, maybe 10, 15 minutes, and then I'll go over the solutions to as many as I can today, and that's what we'll get done for the day. All right, so let's try a few, see what we get through, see how it goes. Just ask me any questions as we go. So if I'm doing anything up here and you're not quite sure where the numbers are coming from, just stop me. So the first couple, I was just asking you to do some multiplication review, but throwing in some other types of fractions, mixed numbers, whole numbers. So like here, the first one we got was 4 3/8 times 7/10. Okay, well, of course, we never deal with the mixed numbers, so we need to convert that into an improper. And so that'd be what? 8 times 4, that's 32. 32 plus 3 is, so that becomes 35/8 times 7/10. Since it's multiplication, you don't have to worry about doing any reciprocal or anything like that. It's just straight across. And so then these do share a 5 in common, though, because 35 divided by 5 is 7. 10 divided by 5 is 2. So on top, you just have 7 times 7. That's 49, and on the bottom you have 8 times 2 is 16. Yeah? So that would be like a perfectly reasonable answer. If you had to convert it, well, how many times does 16 go into 49? Anybody happen to do that? Yeah, 16 goes into 49 3 times, because 3 times 16 is 48. And so you could have written this as 3 and 1/16. If you were going to put it in mixed number form. Okay. All right. Questions on that one? Again, either answer is fine, but you should be able to go between the two. All right, the next one, you can just ignore the signs until the end, basically, because we know the rule. This thing's going to come out what? Negative. It's got to come out negative. So we can just focus on the actual multiplication. But first you need to turn them into impropers. So 3 times 4 is 12 plus 2. This would become 14 thirds. And then this is going to be 8 times 1 is 8 plus 1 is 9 eighths. This one's negative. And then these have a lot of things we can cancel out, right? Because 14 and 8 are both divisible by 2. So 14 divided by 2 is 7. 8 divided by 2 is 4. And then 9 and 3 are both divisible by 3. So on top, you just have 7 times 3 left. And on bottom, you just have 1 times 4 left. It's going to be negative. So the answer here is going to be negative 21 over 4. Yeah, if you wanted to, then what? This could become a mixed number, right? Because 4 goes into 21 how many times? 5 times, because 5 times 4 is 20, with 1 left over. So either one of those would be.
If you didn't simplify, so like I didn't simplify the 9 and 3,
Yeah.
so I left it as 72/6.
That would be,
Is that why I was wrong?
well, if you didn't take the 3 out, would it be 72 thirds? No, 72 twelfths?
I don't know
It should have
what
been 72 twelfths.
I don't know what I did.
Yeah, you could, no. Actually, I don't know. 70, no. It would be something big. I think your denominator got off somehow.
Probably.
Did you lose your 8? Or you reduced 8?
I reduced the 8 to 2, and this 16 is 8.
Oh, that's because there's a 14 up. Did that do
Oh,
it? It's a 14 in
It
here,
is
right?
close. See, I told you I was just
Yeah,
wrong.
I think it's, yeah. But even so, you should always reduce your fractions. It's like, no, the difference between these two is mostly just like functional. Neither one of these would be wrong, but if you don't reduce a fraction, then that's typically considered wrong. Yeah, so you should always reduce your fractions, if possible. Okay. All right, any other questions on that one? All right, so then the next one, we just got 15 over 22, 3 3/5. Again, we're just doing some changes here to the format. 5 times 3 is 15. 15 plus 3 is 18. And lots of stuff can go on here, right? Divide by 5 on top and bottom. Divide by 2 on top and bottom. So you got 3 times 9 on top, which is 27. And 11 times 1 on bottom, which is 11. So that'd be your mixed number answer. 11 goes into 27 2 times, because 2 times 11 is 22, and then that would be 5 left over. So that would also be your mixed number. Okay. All right. Just stop me if you have questions. So this one, let's see. What happens here? Put them into impropers. So 9 times 4 is 36. 36 plus 4, this will become 49ths. Don't lose your negative. And then 16 times 5 is 80, I think. Is that right? 16 times 5, 80. I think so, 80. And then 80 plus 13 would be 93 over 16. There's a lot of simplification that can happen here. So then, like 93 and 9 are both divisible by 3, I think. Right? So 9 divided by 3 is 3. And 93 divided by 3 is, you can plug in your calculator. I think it's 31. Yeah. And then 40 and 16 are actually both divisible by 8. So like 40 divided by 8 is 5. And 16 divided by 8 is 2. So what you have left on top is you have 155. And on the bottom you have 3 times 2, which is 6. Don't forget this was a negative times a positive, though. So your final solution should come out negative. And so you get that 155 out of 6. And then that's the problem I was showing you earlier up on here that was simplified. Well, how many times does 6 go into 155? Well, it's going to be 25 times. And you could do the long division. Just put 6 into 155. Excuse me. 6 goes into 15 2 times, because 2 times 6 is 12. So remainder is 3. And you bring down your 5. And 6 goes into 35 5 times. 5 times 6 is 30, so your remainder is going to be 5. So it's 25, that's your whole number, and then 5/6 would be the mixed number form of that solution. Okay. Yeah? What questions do you have from any of those examples? Okay, it's mostly just practice, and just make it, I mean, the more practice you get, the less little mistakes you'll make. And then the conversion process, this is something I think that people are a little less familiar with, is, going from the impropers to the mixed numbers. So if you come across those, you're still struggling with those, just let me know, and we can do more examples, or I can help you one-on-one too. So, all right. So then we moved on to some division problems. So 5 1/3 divided by 4. Well, we want to immediately rewrite that. Okay, so first I'll turn this mixed number into an improper. So 5 times 3 is 15 plus 1. That's 16 over 3. 4 is 4 over 1. Right? And then you just flip the second fraction. So that 4 over 1 will become multiplying by 1/4. Always the second one that gets flipped. This one simplifies because 16 and 4 are both divisible by 4. And so you just have 4 times 1 on top is 4. 3 times 1 on bottom is 3. So that would be 4/3. And if you wanted the mixed number, 3 goes into 4 one time with 1 left over. So that would be your mixed number answer, 1 1/3. Okay. How you guys feel? Pretty good? Okay. So the first 2 weeks of this class is really just all about just skill building. So if this stuff's really familiar for you, then that's really good. And if it's not, then it's good to get the practice in. We'll do more applied problems as we go later in the course. So hopefully it's not too, I'm not trying to just bore you guys to death, but it is important to have the skills, So later on when you run into fractions, it's not like, oh my gosh, what do I do with these things? All right, so then we got, negative 12 divided by 3 3/11. And so you got, so here's negative 12. That should be written as a fraction, right? So we always rewrite our whole numbers as fractions. And then 3 3/11. So 11 times 3 is 33. 33 plus 3 is 36. And then it's over 11. It's the second fraction that always gets flipped. So this will become negative 12 over 1 times 11 over 36. Well, these are both divisible by what? 12 and 36 can be simplified because what are they divisible by? They're both divisible by 12. So 12 divided by 12 is 1. 36 divided by 12 is 3. So you're just left with 1 times 11 on top, 1 times 3 on the bottom, and a negative by a positive is negative. So negative 11/3. And 3 goes into 11, 3 times? With 2 left over. So that would be your mixed number answer for that one. All right. Let's see, what else? We got this. Then you got this one has 2 mixed numbers, but that's not really an issue because anytime we see mixed numbers, you don't have to panic. You just rewrite them because 8 times 6 is 48 plus 3. That's 51 over 8. And then over here, you got 8 times 2 is 16 plus 1. Did I do that right? 17? Over 8. Yeah. The denominators will actually end up canceling out because what happens is when you rewrite this as multiplication and you flip the second fraction, the 8's just go away. Yeah. And so you could, this one's a tricky one though, because 51 is one of those weird numbers that seems like it should be prime, but it's actually not. 51 is divisible by 17. So if you take the 17 out of both of them, what do you get? This is just 3. Because it's 3 over 1, which is just a whole number, yeah. Or at this step, you could have done, you can check in your calculator. Just do 51 divided by 17, pull your calculator. It's going to tell you the answer is 3.
So anytime you see a common denominator being divided by each other, you could essentially just do the math. You don't have to do the rewriting.
Yeah, right. Because it's kind of like you're in the same units.
Yeah.
I'm taking 51 eighths and I'm dividing by 17 eighths. Essentially, that's just 51 divided by 17 because they're both in the same units. Yeah. So it'd be the same thing if they were both on ninths or tens. But you'll see it anyways because in the next step when you reciprocate, they just cancel out.
Yeah.
Yeah. Mm-hmm. All right. Okay, so then here we've got a negative mixed number divided by another negative mixed number. But again, the signs aren't really that important because we know this thing's going to end up what? It's got to end up positive, so you can pretty much just forget about the signs at that point. So 5 times 9 is 45 plus 3, so that's 48 over 5. And then 5 times 1 is 5 plus 3 is 8 over 5. And technically, I'll just include that they're still negative. But then what happens? Well, we got to rewrite this as multiplication, and we need to flip the second one, right? 5s are going to cancel. And then, well, what is 48 over 8? Those are both divisible by 8, right? And so this really just becomes 6 over 1, which is just 6. So. Yeah? So as long as you remember the steps, working with fractions, multiplying, dividing is not too bad. It's just turn everything into impropers. If you see division, flip the second fraction, and then you just multiply. Simplify if you can, but it's not too terrible. If you see then I included those 2 complex fractions. So if you see a complex fraction, what's the key? Just rewrite it as a division problem, right? Once you have that in place, then you just rewrite that as a multiplication problem, and then we all know how to handle those. 9 and 3 are both divisible by 3. 2 and 8 are both divisible by 2. And so you'll just be left with 3/4 on that one. Okay. All right. And then for the last one, what was it? Negative 4/5 over 2. How should that be written? Divided by 2, and 2 is like 2 over 1. Yeah. So you just think of 2 as 2 over 1. It's the whole number. The big fraction is where you write the division symbol. But again, we know that we're just going to deal with this as a multiplication problem by flipping the second fraction. And then a negative times a positive, we know our answer is going to be negative. And then 4 and 2 are both divisible by 2. So it looks like you're just going to have a 2 on top and a 5 left on bottom. So, all right. You guys feel pretty good about multiplying and dividing fractions, hopefully? Okay. So then then what we'll do tomorrow we'll just go into the addition and subtraction, which are a little bit harder. So addition and subtraction are just a little bit trickier because you have to have common denominators, and so we're going to get into that stuff tomorrow. So, all right, and I will see you then.